of all, let's take a look at some examples. Let's take a look at these first group of examples, which say decide whether or not each relation is a function, and then give its domain and range. So let's look at whether or not each one of these is a function first. Remember, something is a function if it's going to pass the vertical line test, meaning the x's will not repeat. So if I'm just looking at whether or not something's a function, I only need to look at the x values. And I'm worried whether or not they repeat. Well, here the x's on A do not repeat. So is it a function? Yes. It is a function. So yes, it is a function. X's do not repeat. However, we also want to look at finding this function's domain. We'll use D for domain and R for range. When determining our domain, we want to only again look at our x's. And what we notice is our function on A here is just a bunch of points. So when we actually list out our domain, we want to only list the x values that are on our points because it's not connecting the dots, it's just a bunch of isolated points. So we want to only include the x values, the points that we actually have on our graph. So this means that I want to use my list notation, which is those set braces. So what am I going to include in there? Well, I've got the numbers 3, 5, 8, and 9, and then I'll close my set braces. However, when I use set braces, I don't need to put things in order. When I do interval notation, I do, because we're always reading things from smallest to largest when you have a start and an ending value. But we don't if we're using this set notation. But if you're worried about forgetting, I would just get in the habit of putting everything in order. Now let's take a look at range. For range, we're looking at the y values here, and we're going to do the same thing. We've just got a bunch of points, so we just need to only list the x values we have as our possibilities. Well, we've got a 0, a 3, a 4, and an 8, and those will go in little set braces. And we're done. Take a look at B. In B, if we start by looking at the x values, what we'll notice right away is that we have a set of x values that repeat. The 9s repeat, which means that this graph is not a function. It won't pass the vertical line test because we'll have 2 points on top of one another because they have the same x values. So it is not a function. It won't pass the vertical line test because x's repeat. So the x's repeat, and it means it's going to fail the vertical line test. That's for B. Now we can also find the domain still, though. So let's look at finding the domain. Again, our relation, we said it wasn't a function, is going to be looking at its x values, which is a 9, a -3, and a 9. And it's just those values. It's just a bunch of points. So when I do my list notation, my set braces here, I only need to include the -3 and the 9. I know that the 9 appears twice, but once the possibility is in my list, it's already in my list. I don't need to include it again. So be careful. Don't write things in your list twice. It's like double counting. You don't need to do it. Now let's take a look at the range, which means I'm going to take a look at the y values, which are a -2, a 5, and a 2. Again, we don't have something as a function. We're still going to find its range. We've just got a couple specific y values to include. So we'll use our set braces. And what we'll include is our -2, our 2, and our 5, and close off our set braces. And we're done. Now let's take a look at C. Starting over again, let's see if it's a function. If we want to determine if something's a function, we're only going to look at the x values. And notice that none of the x's repeat. So is this a function? Yes, it's a function. So it is a function because the x's do not repeat, which means it will pass the vertical line test. No x's repeat. So it will pass the vertical line test. And I'm going to shorten that to VLT for vertical line test. Now let's talk about its domain. We'll use D for domain, and its range. Let's use R for range. And so for domain, we're only going to look at the x values. And again, even though it's in a slightly different list format as a table, it is still just a bunch of points. So I'm still going to use my set braces and just list out my isolated points. I'm going to get used to going in order just so I don't forget to ever do this. And my smallest is -4, then -2, then +1 and +2. Now let's look at the y values for the range. Well, the y values are still going to go in set braces, and we're just going to list them out. Our values are 0, 3, and 4. Now I do see another 3, but I don't actually need to write that. Once something is in my list, I don't repeat. You just leave it there. It's already there. We don't need to write it twice. Continuing along with D, let's look to see if we have a function first. So by looking at our x values, and what we'll notice is we do have repeating x values. So is it a function? No, it's not a function. It will not pass the vertical line test because we have repeating x values. Then we can move on to looking at its domain. With its domain, again, we're going to look at its x values, and we've just got a bunch of points, so I just need to list those. When we're listing, we're going to use our set braces. And let's see, we've got the numbers -4, 1, and 2. Those are our only possibilities. I do not want to include the -4 twice, so I'm just done. Then I can move on to my range, which means I'm going to look at my y values. Well, my y values or options or possibilities are 0, 3, and 4. And again, I do not want to repeat the 3. And I'll put those in set braces just like the domain, and I am done. Continuing along, let's take a look at E. Now we've got an actual picture graph that starts somewhere and ends somewhere. So now we're looking at something a little bit different. So in order to determine whether or not this is this is a function, first of all, it's going to be easiest to look at this using the vertical line test. So draw some vertical lines. Is there any way to draw a vertical line that will hit more than once? And the answer is no. All vertical lines will hit at most once. So the question is this a function? And the answer is yes, it's a function. Why? Because it's going to pass the vertical line test. Any vertical line is only going to hit the graph at most once. Now let's talk about finding this graph's domain and this graph's range. We'll start with the domain first. Now when you're looking at a graph's domain, we're going to start by reading this from left to right. So we're going to start on the left side at -infinity, working our way from smallest to, we'll work our way to the largest, the right-hand side, to infinity. We're going to say, where does our graph start and where does it stop? That's the domain. It means the only parts of this picture that I care about is where I actually have a graph where I can plug things in and get things out. And if we trace along the x-axis, what we notice is our graph starts here at -2. So that's where we're going to start. Our domain is at -2. And then it continues all the way until it ends here at an x value of +2. Then if we keep on going towards the right, notice there's no graph after that. So we only have a graph in here in the middle between -2 to +2. So the question becomes, am I going to put brackets or parentheses at the -2 and the 2? Well, we see these closed circles. So even if we weren't sure, whenever we see closed circle, that means there's a point there. It means we need to include the values. Whenever we're including values, we're going to automatically use a bracket. Remember, parentheses mean to not include a value. Brackets mean to include the value. And that's it for the domain. But we still have to figure out what the range is. So working on the range, we're going to do something very similar. We're going to start from the bottom end at the smallest values at negative infinity. And we're going to work our way up towards positive infinity. And so the question is, where does our graph start? So if you work your way from down at the bottom all the way up, what you'll notice is that your graph starts somewhere here in the middle, which is here at 0, comma, it does, let's see, keep on going for a while, let's see, if you keep on going, and then it stops here at 3, it looks like. And then if we were to continue, what you notice is there's no graph up beyond 3, so that's why we stopped at 3. So we've got a graph on the y-axis working your way from the bottom to the top from 0 to positive 3. So our range is going to start at 0 and end at positive 3. The question is, what are you going to have at 0 and at 3? Well, if you weren't sure, at 0, notice we have closed circles. So even if you weren't sure, you'd say, well, that means there's points, I need to use a bracket. Where you might get confused is here at positive 3 because you don't see a point. But remember, wherever you have a graph, you technically have a point. That's what a graph is a bunch of points. So even though you're not seeing it, there's a point there at 3. So we're going to use a closed bracket there and include 3. Let's take a look at F. Notice F is a circle, and notice that if we draw a vertical line pretty much almost anywhere, it's going to hit the circle in more than one spot at 2 places. So it is not a function because it does not pass the vertical line test. However, let's take a look at finding its domain and its range. And again, with the domain, we'll start by going from left to right, starting out with the smallest end, the negative infinity end, and working our way over to the positive infinity end. So notice if we do that, starting at the negative end, we'll start here at negative 3. So that means we'll start our domain at negative 3, and then it will continue all the way to, I don't see anything past positive 3. So there's a graph everywhere in the middle from negative 3 to positive 3, but nothing after positive 3. So you only have this graph in the middle here from negative 3 to positive 3, and there's a graph everywhere in between. So that's why there is a domain of negative 3 to 3. The question is brackets or parentheses. Again, even though you don't see them here at negative 3 and 3, there's a graph there. So there is a point there at negative 3 and there is a point there at positive 3, which means we should be using brackets and including those values if there are points there. When you're finding domain and range, you're asking, where do I have a graph? Well, I have a graph at negative 3 and I do have a graph at 3. There's points there, so I should be using closed brackets. Now let's take a look at the range. Working the range the same way, we're going to start at the bottom down at negative infinity and work our way up towards positive infinity. Notice working our way up, the graph doesn't start until negative 3, but does continue all the way through until positive 3, and then there's no graph after positive 3. So there's a graph from negative 3 on the low end to a high end of positive 3, and there's a graph everywhere in between. So same idea as before, we've got a graph starting at negative 3 and ending at positive 3. And again, just like with the x's, there's a point that you can't see. It's there, though, at negative 3. And there's a point at positive 3, so we should be using brackets for our range at negative 3 and 3, including those values.